Chemical reactions occur when two glasses with specific chemistries interact during a kiln firing and form a third color. When using Wissmach glass styles that contain copper and those containing sulfur have reactive potential when combined. In this video, I will explain what chemical reactions are, what to expect when exploring chemical reactions in kiln-formed glass, and discuss a special color that chemically reacts to itself. Now let's get started. See our color reactions tip sheet for a full list of glass styles with reactive potential. Cool colors such as blues and greens often contain copper, and warm colors like yellows, reds, and oranges often contain sulfur. When the colors interact during a kiln firing, they form copper sulfide. Copper sulfide can be seen as a dark line or area where the two colors meet. The dark line will not occur if the colors used do not have reactive potential, as is the case between the color on the top and the color on the right of this image. Utilizing chemical reactions as a design element can provide a unique and interesting aesthetic. This cast frit object combines reactive blue, gold tone, and classic violet frit. A chemical reaction forming copper sulfide only occurs where the reactive blue and gold tone interact. The random and unique dark patterning becomes part of the design. An image from a microscope will better show where the chemical reactions occur in the object. Glass powders can also be used in interesting ways to create reactive designs. Here we used a base sheet of oyster pearl and transparent sky blue frit powder on top. Because the grains of frit powder are so small, the blue almost completely changes to copper sulfide. Looking through the microscope, notice the darker tones near the top right, where the application of the frit powder was thicker. Even thicker applications, or applications using opaque colors, can result in the true color of the frit showing on top of the chemical reaction. It's important to note that not all colors that contain copper or sulfur will react in the same manner when combined. Notice how dark the reaction is between the reactive blue frit and the orange-red sheet glass. The pale green frit doesn't react as strong to the red-orange. This is because the pale green has less copper. Some combinations may not show any chemical reactions due to low concentrations of one or both materials. We recommend testing combinations from our full list to see what effects you can achieve. The Wissmach catalog also contains glass styles that mix two highly reactive colors into a single Prisma sheet. Reactive blue has some of the highest concentrations of copper, and oyster pearl, sulfur. 9637 and 9639 are a mix of both colors to create an extremely reactive sheet of glass when fired by itself. This is the same piece of glass after firing. All three of these samples were cut and assembled from the same piece of 9637. Because each sheet is handmade at the Wissmach factory, each area of the sheet can react in different ways. Reactive Prisma styles can be used for any number of kiln forming projects. Pairing reactive Prisma styles with other glass that also has reactive potential can give you a variety of results. The results can depend on what portion of the reactive Prisma style is used, specifically whether the portion has more copper or more sulfur. Results can also depend on which glass colors are paired with the 9637. To show this, we've made several samples using base layers of 9637. On two of the pieces, we've placed reactive blue frit, which contains copper, and gold tone frit, which contains sulfur. Both being opaque colors, they will retain their full saturation on top of the base layer after firing. We've done the same on a second set of pieces using deep sky blue transparent, which contains copper, and red transparent that contains sulfur. We then fired the pieces to a full fuse. It is easy to see the chemical reactions. The areas of the glass that are still reactive blue or oyster pearl after firing are areas where one color was more dominant and the reaction cannot be seen. It is possible to see a completely different reaction on the bottom of the sheet than it is visible on the top. Looking closer at the frit samples, we can see the variety of effects that one can achieve based on where the frit is placed on the reactive Prisma sheet glass. In the areas where the oyster pearl has remained, the blue has reacted to create dark lines or copper sulfide, but the gold tone has not. This reaction is even more apparent on the second sample. Now let's take a look at the samples using transparent frit. Again, we can see where the chemical reactions are and are not occurring. The red transparent does not react with the oyster pearl portion of the sheet glass, but the transparent blue does. The opposite occurs on the portions of the sheet glass that remained blue. The second piece of 9637 has reacted more uniformly, so the overall results are more difficult to see, but still visible up close. The final sample on the kiln shelf was created using the edge construction technique. Using reactive prisma styles in this manner shows off the cross section where the two colors intermingle and creates unique reactive designs. Quarter-inch strips of 9637 were cut and placed on edge, then fired to a full fuse. We hope this video has inspired you to start exploring chemical reactions in the Wissmach catalog. We can't wait to see what you make.